I am a theoretical physicist, a cosmologist, but also a dreamer. Though I couldn't move and had to communicate with the world through a computer connected to my brain. In my mind, I was completely free. Free to explore the deepest mysteries of the universe. Free to search for an answer to one of the oldest questions in human history: did God create the universe? From the stars close to us to the distant galaxies, science has taken us on a journey through the laws of nature. A journey that leads us to the ancient secrets of the universe, how it was formed and how it operates. This is what the brilliant mind of Stephen Hawking dedicated his life to. And he was proud of it. In fact, Hawking was perhaps the first, and the only person so far, to come the closest to the truth about God that humanity has ever known. His research, his declarations, and his scientific viewpoints have all painted an almost complete picture of the universe in the most logical way possible. So today, let's take a closer look at the grand blueprint drawn by one of the greatest scientists in human history. And perhaps, in the process, you may find an answer to the question, did God create the universe? And if so, who created God? Throughout history, there has always been one question. A question that has echoed through time: who, or what, created and governs the universe? In ancient times, the answer was always the same: God created everything. And in a world filled with fear and uncertainty, this belief was a source of comfort. Even the mighty Vikings, known for their strength and courage, relied on supernatural forces to explain natural events like lightning and storms. The Vikings had many gods: Thor, the god of thunder; Loki, the trickster; and Odin, the supreme ruler of the 9 realms. But the one they feared the most, a monstrous wolf named Skoll. According to Viking legends, Skoll was the offspring of Fenrir, the great wolf child of Loki. And when Skoll devoured the sun, the world would be plunged into darkness. The Vikings believed this event, what we now call a solar eclipse, was a terrifying omen. Without science to guide them, they could only rely on the one method they knew, making as much noise as possible to scare the beast away and bring the sun back. For centuries, they held on to this belief. But today, we know the truth. Whether they made noise or not, the sun was always going to return. It turns out, the universe is not as supernatural or mysterious as we once thought. But to truly understand it, we need something even greater than Viking courage. We need curiosity. Because the truth is, an ordinary person, just like you and me, is fully capable of understanding how the universe works. And this has been proven for thousands of years. Let's go back to ancient Greece, around 300 BC. In an era when civilization flourished, one man stood out with an insatiable curiosity about the mysteries of the sky. His name? Aristarchus. Unlike most people of his time, Aristarchus dared to question everything, including the belief that gods were behind astronomical events. One phenomenon fascinated him more than any other: the lunar eclipse. And instead of accepting the idea that it was caused by divine forces, he did something different. He observed. For years, he studied the sky, watching and analyzing. And then, he made a bold claim: the lunar eclipse wasn't caused by gods, it was simply Earth casting its shadow on the moon. With this discovery, he didn't just solve one mystery, he unlocked the door to many more. By carefully mapping out the positions of the sun, Earth, and moon, he reached a groundbreaking conclusion. A conclusion that defied everything humanity believed at the time. Earth was not the center of the universe. Instead, it revolved around the sun. And suddenly, everything made sense. Not just lunar eclipses but solar eclipses as well. When the moon blocked the sun's light from reaching Earth, it wasn't a god devouring the sun, it was simply an astronomical event governed by laws of nature. These revelations changed everything. They proved that the universe wasn't ruled by magic or divine intervention, it was a grand machine operating under precise laws. And those laws? They could be understood by anyone, even you. I believe that discovering these natural laws is humanity's greatest achievement. Because if we understand these laws, they will reveal something profound, whether or not the universe needs a God to govern it. Centuries ago, people believed that individuals like me, those with disabilities, were cursed by God. Perhaps I offended someone up there, but I wanted a different explanation. One that wasn't based on divine punishment. I wanted answers rooted in the laws of nature. Once again, Stephen Hawking firmly asserted his belief in science. He didn't need divine forces to explain the mysteries of the universe. But what exactly are natural laws? And just how powerful are they? To truly grasp this, let's look at something familiar: soccer. The game of soccer is governed by two sets of rules. The first set is created by humans, rules like the size of the field, the height and width of the goal, and the offside rule. These are artificial laws that can change whenever the governing bodies decide. But then, there's another set of rules, rules that are fixed, unchangeable. These laws govern how the ball moves across the field, how it responds to a player's kick, and what happens when force is applied at different angles. These are the laws of nature. The way the ball moves, how it bends, accelerates, or slows down, isn't magic. It's physics. Every goal, every curve shot, every deflection follows precise natural laws. And these laws don't just apply to soccer. They govern everything, from the motion of planets in space to the way galaxies spin in the cosmos. Unlike human-made rules, natural laws can never be broken. They are absolute. And that's where things get complicated. Because if you and I acknowledge that these natural laws are unchanging, then we must ask, what role does God play in running the universe? This is one of the greatest conflicts between science and religion. Even though modern science has only flourished in the last few hundred years, this debate has existed for far longer. Galileo was one of the pioneers who laid the foundation for modern science. He was living proof that if you observed the universe long enough, you could understand everything. Born on February 15, 1564, near Pisa, Italy, Galileo was the son of a musician. Initially, he studied medicine at the University of Pisa but later switched to philosophy and mathematics. In 1589, he became a mathematics professor at Pisa, and by 1592, he had moved to the University of Padua, where he held the position until 1610. During this time, he conducted numerous experiments on the motion of objects, mechanics, and pendulums. In 1609, Galileo learned about the invention of the telescope in the Netherlands. Although he never saw the original design, he developed a superior version himself and made groundbreaking astronomical discoveries. He observed mountains and valleys on the moon's surface, sunspots, the four largest moons of Jupiter, and the phases of Venus. These discoveries brought him fame and earned him a position as the court mathematician in Florence. However, they also led to his downfall. Galileo was accused of heresy for supporting Copernicus's heliocentric model, which claimed that the sun, not the Earth, was the center of the universe. This idea was revolutionary at the time, as most people still believed that Earth was at the center of everything. The Church banned him from teaching or promoting the heliocentric theory. However, his book Dialogue concerning the two chief world systems presented arguments for and against Copernicus's ideas in the form of a discussion. This led to his trial in Rome, where he was found guilty of heresy and sentenced to life imprisonment. Later reduced to permanent house arrest at his villa in Astri, south of Florence. Galileo was also forced to publicly recant his support for the heliocentric theory. However, his work sparked an intellectual revolution, permanently breaking the connection between religion and science. 300 years later, more and more natural phenomena, earthquakes, lightning, storms, and even the way stars shine, were explained by science. Every time science explained a new natural event, the role of divine intervention became weaker. If you know that a lunar eclipse is caused by Earth blocking the moon, you won't believe in Skoll, the Norse wolf that swallows the moon. If you understand that lightning is just an electric discharge from clouds, you won't think it's Thor striking his hammer. Science doesn't reject religion, it simply provides simpler explanations for natural phenomena. But even now, there are still mysteries left unsolved. Does Earth's rotation happen by itself? Or is there a divine hand guiding it? And the ultimate question, did God create the universe? In 1985, Stephen Hawking attended a cosmology conference at the Vatican in Rome. Renowned scientists from various fields gathered, along with the presence of Pope John Paul II. Many of them stated that while we could study how the universe operates, we could never uncover its origin, because that was the work of God. Hawking, however, had a completely different perspective. He firmly believed that humanity would one day be able to explain the origins of the universe through science. "I can't help but be curious," he said. "I believe it is our duty as scientists to understand where this universe came from. And fortunately, it's not as difficult as we might think." To Hawking, the universe, despite its vastness and complexity, was fundamentally made up of just three essential components. So, what are these three components that make up the universe? The first is matter, anything that has mass and takes up space. Matter is all around us, from dust and rocks to ice and clouds, both on Earth and throughout space. The second component is energy. Although invisible, we all experience energy daily. We use it, feel it, and are often amazed by its power. Energy spreads throughout the universe, governing the laws of nature. And finally, the last crucial component needed to create the universe is space. You can describe the universe in many ways: spectacular, mysterious, or wondrous, but the most undeniable characteristic is its vastness. Space is the most abundant element in the cosmos, the very foundation of its existence. This leads to a fundamental question: where did matter, energy, and space come from? For centuries, humanity had no answer, until the 20th century. The breakthrough came from one of the greatest scientific minds in history, Albert Einstein. Einstein made a remarkable realization: the two key components of the universe, matter and energy, are essentially the same. They are like two sides of the same coin. His famous equation, E=mc², demonstrated that matter is simply a form of energy and vice versa. With this discovery, our understanding of the universe shifted. Instead of three fundamental components, we now recognize that the universe consists of only two, energy and space. But then, the next question arises: where did energy and space come from? After decades of research, the answer finally emerged: energy and space originated from a single, random event known as the Big Bang. And now, let me take you through the story of how energy and space came into existence. The Big Bang Theory, often referred to by its English name, is the leading cosmological model describing the early formation of the universe. According to this theory, the Big Bang occurred approximately 13.8 billion years ago, which is also considered the age of the universe as we know it. At its beginning, the universe was in an extremely hot and dense state. Then, it rapidly expanded. As it grew larger, it cooled down, allowing subatomic particles such as protons, neutrons, and electrons to form, while simple atomic nuclei emerged relatively quickly after the Big Bang. It took thousands of years before neutral atoms could exist. The Big Bang Theory is a scientifically verified and widely accepted model. It provides a comprehensive explanation for many observable cosmic phenomena, including the presence of light elements like hydrogen and helium, the cosmic microwave background radiation, the afterglow of the Big Bang, the large-scale structure of the universe and how galaxies formed, Hubble's law, which shows that galaxies are moving away from us, indicating cosmic expansion. One of the key insights supporting the Big Bang Theory is the discovery that the universe is expanding. physicists observed that galaxies are drifting apart, which suggests that in the past, everything must have been much closer together. By rewinding time, scientists realized that the universe must have once been in a state of extreme density and heat. Large particle accelerators have been built to simulate conditions close to those of the early universe, providing valuable insights that support the model. However, these machines have limitations, as they can only recreate a fraction of the immense energy levels present in the first moments of the universe. Here's an important distinction: the Big Bang theory does not describe the exact moment of creation, it does not explain what came before the Big Bang or what caused it. Instead, it explains the evolution of the universe after that initial event. The idea of a primordial atom, a dense, hot beginning for the universe, was first proposed by Belgian priest and cosmologist Georges Lemaitre. Over time, physicists refined his concept, building upon his work to form the modern Big Bang theory. For a period, the scientific community was divided between two competing models: the Big Bang theory, which suggested an evolving universe; the steady-state theory, which proposed that the universe had no beginning and always existed in a constant state. However, in 1964, the discovery of cosmic microwave background radiation provided strong evidence favoring the Big Bang model. Since then, astronomers and physicists have combined observational data, theoretical calculations, and advanced simulations to refine and develop what is now known as the Lambda-CDM model, the standard framework for modern cosmology. But even with all this knowledge, one question still lingers: how exactly did energy and space come into existence? To make it easier to visualize, let's arrange the Big Bang timeline step by step. The first moments of the universe, in its earliest state. The universe was an extremely dense, hot soup of quarks and electrons, moving at nearly the speed of light. Particles constantly collided, annihilating and creating new ones. A fraction of a second after the Big Bang, the universe was filled with charged quantum particles, including quarks and anti-quarks, lighter particles and their antiparticles, called leptons, such as electrons and neutrinos, began to appear. 1 microsecond after the Big Bang, the universe cooled to about 10 trillion Kelvin, 10,000 million K. Quarks combined to form the first protons and neutrons. Leptons multiplied rapidly, dominating the early universe. 1 second after the Big Bang, as the universe expanded and cooled to 10 billion Kelvin, protons and neutrons started fusing into deuterium, a heavy hydrogen isotope. However, the intense energy from photons kept breaking these atomic nuclei apart. 3 minutes after the Big Bang, at 1 million Kelvin, photons no longer had enough energy to break apart atomic nuclei. The first stable atomic nuclei, including deuterium, helium-3, helium-4, and lithium-7, formed in a process known as Big Bang nucleosynthesis. By 15 minutes after the Big Bang, nuclear fusion slowed down as the universe became too cool for further reactions. 300,000 years after the Big Bang, the birth of atoms, the universe cooled below 3000 Kelvin, becoming transparent for the first time. Electrons slowed down, allowing atomic nuclei to capture them, forming the first neutral atoms. This marked the moment when photons could travel freely, releasing the cosmic microwave background radiation that scientists detect today. The formation of galaxies and stars, billions of years later. Gigantic clouds of gas began to collapse under gravity, forming the first galaxies. Within these galaxies, stars started forming, shining as nuclear fusion ignited in their cores. Meanwhile, the universe continued expanding, leading to the vast cosmic structure we see today. This entire process, starting from a dense, hot beginning to a structured universe filled with galaxies, stars, and planets, illustrates the incredible transformation of energy and matter over billions of years. The Big Bang theory is one of the most fascinating explanations for the origin of the universe. Over the years, three major astrophysical discoveries have provided strong evidence for this theory. 1. The expansion of the universe, 1929, Hubble's discovery. In 1929, Edwin Hubble made a groundbreaking observation: the light from distant galaxies was redshifted, meaning their wavelengths stretched toward the red end of the spectrum. This indicated that galaxies were moving away from us, and their speed was proportional to their distance. This discovery proved that the universe is expanding. If we reverse time, all galaxies would have once been much closer together, leading back to a single origin point, the Big Bang. 2. Cosmic microwave background radiation, 1965, Penzias and Wilson's discovery. In 1965, physicists Arno Penzias and Robert Wilson detected an unexplained radio noise that appeared the same in all directions. This mysterious signal matched the predicted leftover heat from the early universe, what we now call the cosmic microwave background radiation, CMB. This radiation is essentially the oldest light in the universe, emitted when the universe first became transparent, about 300,000 years after the Big Bang. As the universe expanded, this ancient light stretched into the microwave spectrum, aligning perfectly with the predictions of the Big Bang model. 3. The abundance of light elements, 1970s, discovery of helium and deuterium. By the 1970s, scientists had analyzed the composition of the universe and found that helium-4 made up about 25% of all matter, while deuterium, helium-3, and lithium-7 also existed in predictable amounts. These precise ratios could only be explained if these elements were created during the first few minutes of the Big Bang, when the universe was still hot enough for nuclear fusion to occur. The ultimate mystery: what happened before the Big Bang? Even with these strong pieces of evidence, the ultimate question remains unanswered: what existed before the Big Bang? Modern physics takes us back to 10-4 cubed seconds after the Big Bang, known as Planck time, but beyond this point, our current understanding breaks down. The universe was incredibly hot, 100 trillion Kelvin, and classical physics no longer applies. To answer this mystery, scientists need a quantum theory of gravity, a framework that unites Einstein's general relativity with quantum mechanics. Until such a theory emerges, the origin of the Big Bang remains speculative. Some argue that before the Big Bang, there was nothing, but what does nothing really mean? Was there a previous universe, a cosmic cycle, or something beyond human comprehension? Religious perspectives often propose that a divine force set the universe into motion. But if God created the universe, then who created God? This is the boundary where science meets philosophy. And for now, the answer remains one of the greatest mysteries of existence. Who created God? This question isn't just something skeptics ask, many believers have wondered about it too. God, the Supreme Being, the Almighty, these are the names people use to describe the most powerful supernatural entity. But if Christians believe that God created the universe and humanity, then a logical question follows: who created God? Where did he come from? Most people asking this question rarely receive a satisfying answer. The issue lies in how we perceive causality. Everything we see, everything we experience, follows the law of cause and effect. Every material thing must have a cause. At least, that's true for the physical world as we understand it. If we accept this law, then logically, the universe itself must have a cause. But here's the catch, that cause cannot be material. Why? Because if the cause of matter was itself made of matter, we'd be trapped in an infinite loop, asking the same question over and over. So at the very beginning of the material world, its cause must have been something beyond the material, something immaterial. Now, as mentioned earlier, the law of cause and effect only applies within the physical universe. But God is spirit, he exists outside these laws. If God created the material world, then he also created the very rules that govern it. It's a difficult concept to grasp. But consider this: different things have different properties. For example, Color has a source, light's spectrum, but if someone asks, what does blue smell like? There's no answer. That's because colors don't have sense. Likewise, God doesn't require a cause the way material things do. Humans can trace the origins of physical matter, but we cannot apply those same rules to the divine. God does not belong to the category of things that need a cause. He is outside that framework. Secondly, we tend to search for causes by looking backward in time. That's because everything material exists within time's flow. But time itself is part of creation. God, however, does not exist within time the way we do. And this is where things get tricky, because we have never experienced existence outside of time. We cannot fully comprehend it. Think about it, we don't even know when time began. If someone claims there was a first moment, the immediate question arises, what came before that? But for God, there is no past or future, only the eternal present. He has no beginning and no end. So, if we conclude that the universe exists purely by chance, we contradict the very laws of cause and effect that govern the material world. Even the Big Bang, the starting point of everything, wasn't truly random. The physical world, by its very nature, demands a cause. And that cause cannot be material. And that aligns perfectly with the belief that God was not created, nor is he the result of anything else. Instead, he is the very cause of everything that exists. Beyond that, we have to ask, could a universe as orderly and beautiful as ours really emerge purely by chance after an instant explosion? Could an intelligent species like humans, capable of creating artificial intelligence, simply appear as a random accident? Does that truly align with the chaotic, unpredictable nature of the material world? The universe is incredibly structured. And order does not arise from randomness, it requires an intelligent cause. Something purposeful and deliberate. Stephen Hawking once stated that the universe doesn't need a cause. That the laws of nature themselves are sufficient to explain its creation. This idea has been widely embraced by atheists, as it aligns with their belief in a self-sustaining universe. However, while the universe operates under natural laws, those laws themselves did not randomly assemble into a perfect, self-regulating system. Isaac Newton, one of history's greatest physicists, had a different perspective. Unlike Hawking, Newton believed that God was the creator of both the universe and the laws that govern it. There's a famous story that illustrates this belief. Newton and astronomer Edmund Halley, who discovered Halley's comet, were close friends. Halley, however, was a skeptic and often debated Newton about the existence of God. One day, Newton built a model of the solar system, a beautifully crafted piece with a golden sun at the center and planets orbiting around it in perfect harmony. A small crank allowed the planets to move in their correct orbits, with light shining at different angles to create a breathtaking display. When Halley visited Newton and saw the model, he was captivated. He studied it for a long time, admiring the craftsmanship, and finally asked, "Who designed this?" Newton, with a knowing smile, replied, "No one. It just formed randomly on its own." Halley immediately scoffed. "That's impossible. Someone had to create this. Whoever did it is a genius." Newton then placed his hand on Halley's shoulder and said, "This model is nothing compared to the actual solar system. If you believe this tiny model required a creator, then how could the real thing, infinitely more complex, exist without one?" What many people forget is that Newton, the very scientist who formulated the laws of gravity, was also a theologian. He believed deeply in an all-wise creator who not only made the universe but also designed the very principles that keep it in motion. So, does God exist? Did he create the universe? These questions will continue to be debated for eternity. Because when you believe something, you will always find ways to defend it, and challenge opposing views. But in the end, what matters most is that we respect one another's beliefs and engage in thoughtful, reasonable discussions. When we do that, The question of whether God exists, and who created him, might no longer feel like an unsolvable mystery. If you enjoyed this video, don't forget to subscribe and leave a like. Thanks for watching.